Hey guys, Raz here, and today we'll be looking at discriminants. So firstly, what is a discriminant? It's pretty simple. If we consider the quadratic formula, then from experience, I'm hoping that you realise that when we use the quadratic formula, it messes up when this bit is less than zero. Yeah. So if you solve a quadratic using the formula and you get this equal to less than zero, what you'll get is a math error on your calculator. So, and hopefully you would have noticed different results when we got a result that was equal to zero or greater than zero. Yes, so when we had a math error, that meant that we didn't get any solutions from it. When we got this equal to zero, it disappeared. So essentially we get one answer, which is whatever minus b over 2a was, yeah? So when the bit under the square root was equal to zero, we had one root or one solution. And if it's solved as normal, and this ended up being greater than zero, then that gave us two solutions. So it's this part here, not including the square root, which is known as the discriminant. Yes, so what we're going to go into now is, why that's useful. So I've got three examples here, sorry, and that explain what I've just explained. So the first one, obviously pause the video and give it a go if you want. If we solve that using the formula, we get two solutions which correspond to the points at which the curve intersects the x-axis. Yeah? If we solve this one, we can see that would factorize to x minus 1, x minus 1. So we have a repeated root here, which means the curve is a line. Sorry, the curve is a tangent. The x-axis is a tangent to the curve. Yes, so there's one solution. So that means the x-axis touches the curve, opposed to intersecting it. Now this one is when we got math error in our calculator. And that would coordinate to no solutions, which just means the curve does not cross the x-axis, yeah? They do not meet. So if I'd evaluated the discriminant in each case, so for the first one, we would have had b squared minus 4 times 3 times 7, which would have been minus 7. 4 times 3 times minus 7. So we would have got 4 minus 12 times 7, which is clearly bigger than 0, hence two solutions, which we can see was the case. If we did here the discriminant, what we've got is minus 2 squared minus 4 times 1 times 1. This ends up being 4 minus 4, which is 0. Therefore, one solution, which again is what we saw. If we do this one, b squared minus 4ac, we have minus 2 squared minus 4 times 3 times 7, which is 4 take away 84, which is clearly less than 0. Therefore, no solutions. i.e. the curve does not meet the x-axis. Whilst here we can say the curve would just touch the x-axis, and in the first case, the curve intersects the axis at 2 points. So that is a discriminant, and this is the first instance at which we would use it. So now what I'm going to do is just do a load of questions for you to see sort of thing where we might utilize that bit of information that is given to us in the question, because that's what it's about. You have an exam question and they'll drop that little bit of information and you need to use it to be able to solve the question. If you don't identify that that is a bit of information, you will not have enough to answer the question. So here, by calculating the discriminant, work out the number of solutions to the equation 3x squared plus 5x minus 9. So it just tells me I don't need to solve anything. It's made the question a bit easier for me. So we need to evaluate b squared minus 4ac. So we have 5 squared minus 4 times 3 times minus 9, which equals 25 minus 12 times 9. So which equals 133, which is greater than 0. Therefore, the curve, the equation has 2 real solutions. So any positive solution we say is real because it has real numbers. We don't do complex numbers at this level. But so if you get 2 solutions, you say 1, you say 2 real solutions. If you get 1, you say 1 real solution. I suppose you don't have to say it, but if it's in the question, that's what it's referring to. Okay, next one. Find the discriminant of this. Again, the question is quite a kind one. We're just going to evaluate this. So evaluate this. So this time b is k plus 1 minus 4 times k squared minus 2, and c is minus 2. So find the discriminant of this. So we just need to expand it and simplify. So we have a k squared plus 2k plus 1 minus whatever this thing ends up being. So minus 2 times 4 is minus 8 times k squared minus 2. So we've got k squared plus 2k plus 1 minus 8k squared plus 16. So we've got k squared plus 2k plus 1 plus 8 squared, because of minus times a minus 16. So we have 9k squared plus 2k minus 15. So that would be the discriminant there. We can't do anything with it because they haven't given us any more information. Yeah. Had the question has said there are 2 real roots, we would set that greater than 0. If the question had said there was 1 root, we would set it equal to 0. And if the question had said that there were no real roots, we would set this less than 0. And in each case, solve that to figure out the range of values for k. So hopefully that's what we're leading on to now. So we're given this equation and we're told it has equal roots, find the possible values of k. So we're going to evaluate the discriminant. So we have 4k plus 1 squared b squared minus 4ac, c which is 1, or c. So we don't need to put any x's in there. We're just putting the coefficients in. That's the important thing. And we're told it has equal roots. So we're going to set the discriminant equal to 0. So equal roots means one root. Now let's just expand this. So that will give me 16k squared plus 4k plus 4k plus 1 minus 4k squared. So that gives me 12k squared plus 8k plus 1 equals 0. And then we just solve this quadratic. We solve this, we could use the formula. We could use the formula or factorize. I think I've seen the solution here. So 12k squared plus 6k plus 2k plus 1. And that works. So therefore, k equals minus 1/6, or k equals minus a half. You would have got the same solutions if you use the formula. It's absolutely fine to use the formula. It's just a bit quicker for me to do it that way. So find the possible values for k, minus 6, minus a half. All right, next one. This time we have two distinct real roots. Find the range of values of k. So b squared, 3k minus 3 squared, minus 4 times a times c. Two real roots means this is greater than 0. So I need to expand the left-hand side and simplify first. That's the only thing to do. So that would be 9k squared minus 9k minus 9k plus 9 minus 4 times that. So minus 8 squared. So 8k squared plus 8. So that gives me k squared minus 18k plus 17 is greater than 0. We get k minus 17, k minus 1. So therefore, if we're solving this quadratic inequality, where is this function bigger than 0? Well, here and here. So it's to the left of 1 and the right of 17. So find the range of values. K is bigger than 1. Sorry. Find the range of values. K is less than 1, but more than 17. Yeah? Excellent. Let's do one more. So we're told this has no real roots. So first thing we need to do is set everything equal to 0. So if we set everything equal to 0, we have 3kx squared plus 2kx minus 4x minus 3 has no real roots, so is less than 0. So now we need to group our terms. We have a 3k squared. We need to factorize this bit. So that's 2k minus 4x. So now we can evaluate b squared minus 4ac is less than 0. Those should be equal signs. Right, now let's look at this question. So first thing we need to do is set this equal to 0. So we get that. So let's bring everything to the left-hand side. Now we need to group the terms. Yeah, so we have a 3k squared, which will be our A, but we need to factorize this 2k minus 4x, which will be our B, and minus 3 is our C. So we need to evaluate B squared minus 4AC, because it's no real roots, is less than 0. So we know that 2k minus 4 squared minus 4AC is less than 0. So what does this give us? This gives us 4k squared minus 8k minus 8k plus 16. And this is minus 12 times 3k. So minus 36k times by that negative. So we have 4k squared So we have 4k squared minus 16k plus 36k plus 20k plus 16 is less than 0. Well, there's a nice common factor of 4 there. So that'll be k plus 4, k plus 1 is less than 0. Like all the others, if it didn't drop out nicely, like it did here, we would just use the formula to solve it, yeah? Just use the quadratic formula. But we don't need to here. So we get these solutions. What does that mean? Where is that graph less than 0 in that region? So k is between -1 and -4. So find the possible values of k. K is between -1 and -4. So quadratic inequalities are a big part of this topic. So if you're finding those difficult, watch my quadratic inequalities video. Obviously, don't forget to like and subscribe. I've been Raz. I've hoped you'd enjoy that. See you soon.